task, it means that we cannot put every single number there. So we're going to be strategic. This is the set of numbers we need to put in our function. It's almost impossible. So we are going to be strategic and then use only 3 sets of numbers. And the 3 sets of numbers we are going to use are 0, any positive number, any negative number. All right, these are only the 3 sets of numbers that we are going to test to see, because it's impossible to test all numbers. So our first number, in no specific order, that we are going to use is 0. We put 0 into the function, meaning wherever we see x, we put a 0 there. So here we are going to have f of 0, that is 2 times 0 minus 1, and that's 0 minus 1, which is equal to -1. -1 is a real number. Therefore, 0 is part of the domain. Then we come to the right-hand side and pick any positive number, put that positive number into the function. Let's pick any positive number, maybe 5. So we put 5 into the function, and we have 2 times 5 minus 1, that is 10 minus 1, which is equal to 9. 9 cedis is real. Therefore, all positive numbers are part of the domain. Then we come and pick any random negative number. So if we pick positive 5, let's pick -5. We put -5 into the function, and that will give us 2 times -5 minus 1, which is equal to -10 minus 1, and that is -11. You are owing somebody 11 Ghana cedi. That is real. Therefore, negative numbers are part of the domain, meaning all the numbers on the real number line are part of the domain. We can't put -infinity in there because it will make the function undefined. We are not going to put positive infinity in there because that is what we are going to avoid. That is what we want to avoid. If you put infinity here, you have 2 times infinity, that is infinity. Infinity minus 1 is still undefined. That is how come we are not testing -infinity. We are also not testing positive infinity. So with this type of function, y is equal to 2x minus 1, we've seen that the domain, which is all the numbers we can put in the function, the domain is all the numbers on the real number line. So the domain D is x is such that all x must come from the real number line. That gives us the domain of the function. One more example, then those who have questions, you may ask. Another example of the linear, y is equal to, maybe let me put a negative here, -3x plus 4. This is also another type of linear polynomial because the highest power is 1 and it has multiple terms. None of the exponents is negative nor fraction. To find the domain of this function, we are looking for numbers to replace the x with, and the answer must not be either negative nor or positive infinity. And the numbers you are looking for are all the numbers on the real number line. This is difficult task, and so we employ a strategy. We are not going to test all the numbers on the number line. We are going to test only 3 types of numbers, and the 3 types of the numbers we are going to test are 0, we'll test 1 positive number, we'll test 1 negative number, meaning we are going to put 0 in place of x, find the result. We are going to pick any random positive number in place of the x, find the result. Then we'll pick any negative number, put it in place of the x, we find the result. If none of the results is either negative or positive infinity, it means that all the numbers on the real number line forms part of the domain. So our first number we are going to test is 0. This is the same as f of x. So we put 0 into the function. this will give us minus 3 times 0 plus 4, and that is 0 plus 4, and that will give us 4. 4 is a real number. Therefore, 0 is part of the domain. Then we go to the right-hand side. Pick any positive number, maybe 100. We put 100 cedis into the machine, and we are going to get minus 3 times 100 plus 4. That is minus 300 plus 4. That is minus 296. That is a real number. Therefore, all the positive numbers are part of the domain. Next, we go to the negative side. We pick any negative number. So if we pick positive 100, let's pick the negative counterpart. Negative 100 into the function, we have minus 3 times minus 100 plus 4, and that will give us 300 plus 4, and that is 304. 304 is a real number. Therefore, all negative numbers are part of the domain. We are not going to test the minus infinity because it will make the function undefined. We are also not going to test the positive infinity because obviously it is going to make the function undefined. Therefore, the domain of the function is a set of all numbers on the number line. And the set of all numbers on the number line are called real numbers. And so the domain of our function D, in the domain, which of the variables are we looking for? X. So the domain is the set of all x's such that x must be a member of all real numbers. Any questions so far? All right, so if there are no questions, we have seen that when the function is...
There are questions.
Okay.
Madam, please, can we also solve some which are not real numbers for us to see if...
Yeah, we'll get there. We'll get there.
Oh, okay.
There are some that are not the set of all real numbers. We'll get there. But questions on these. Is it clear on just the linear?
Yes,
Madam,
please.
please, I want to ask, I
Okay.
can put any question to represent the X, right?
You can put any number.
Any number, sure, sorry,
Yes.
any number.
Any number at all.
Okay, thank you.
All right. All
Madam,
right, so yes.
please, so assuming if you put in the positive side, you put 10, can you change the negative side, or you just have to
No,
use
it doesn't
the
need to
same
be
number?
negative. No. Maybe on the positive side, you decide to pick 1 million.
Okay.
On the negative side, you can decide to pick -2.
Okay,
Any
so
number at
choosing
all.
that, it won't affect your answer.
No, it will not affect it. It will not
All right,
affect
thank
it
you.
at all. Any number, yes. All right.
Madam,
Yes,
please. So
please.
this is just to define the domain.
Very good. This is to find the domain.
Oh, okay.
Yeah, this
So
is just
a question can be put out that find the domain of the linear equation.
exactly. No. It will be find the domain of this polynomial.
Oh, okay. Okay.
Yeah.
Thank
It
you.
will not be so straightforward. You have to, as we are going, all right, let's put
All right.
the domain aside. We've seen
Okay.
2 examples of linear, and the
Yeah.
domain is always the set of all real numbers.
Yes, ma'am.
We'll go on to highest power, other higher power. We go to 2, we go to 3, and then 4. We'll see a trend so that we can always generalize. And then it will get to a point where you don't even need to do what we are doing now, because there
All
is
right.
a loophole that we are trying to get to.
Oh, okay. Thank you, ma'am.
Yeah, you're welcome. All right, so if it's linear, the domain is the set of all real numbers. So for linear, the domain is always the set of all real numbers. So in exam, you have been given a linear. y is equal to 4 over 3x plus 1. This is linear. Power on top of the x is 1. Power on top of this x is 0. We have not disobeyed the rule of polynomial. So this says yes, it's a linear polynomial. As soon as you see that, find the domain of this linear function. Quickly, the domain is a set of all real numbers, which is your R here. All right, so you don't need to go through what we have done here at all. As soon as you see that the function that whose domain you are trying to find is linear, don't work anything out. You just write it is going to be the set of all real numbers. Now let's look for when the power is 2. When the power is 2, we are looking at functions of the form ax squared plus bx plus c, and that is quadratic. To find domain of quadratic, example, maybe 2x squared plus 3x minus 1, we follow the same approach or the same strategy we use in the linear function. We want to find the set of all numbers from minus infinity to positive infinity with 0 in the middle. We are going to put these numbers into the function. Once again, this is the same as f of x. We are going to put these numbers into the function. Wherever we see x, we put the number there. So we employ the strategy that we are going to use only 0, any positive number, any negative number. Then we can conclude. All right, so if we put our first number in there, which is 0, f of 0 will give us 2 times 0 squared plus 3 times 0 minus 1, and that is minus 1. Minus 1 is a real number. Therefore, 0 is part of the domain. Then we go to the right-hand side, pick any positive number. Let's pick 1. If we put 1 into the function, we are going to get 2 times 1 squared plus 3 times 1 minus 1, and that is equal to 4. 4 is a real number. Therefore, all positive numbers are part of the domain. Now, the last bit is we go to the left-hand side. Pick any negative number from the left-hand side. If we put maybe negative 2, if you put negative 2 in the function, it means we are finding f of negative 2, and that is 2 times negative 2 squared plus 3 times negative 2 minus 1. Here we'll have 8 minus 6 minus 1, and that is 1. 1 is real. Therefore, all the negative numbers are part of the domain. Like we stated, we are not going to test the minus infinity because it will make the function undefined. And we are not going to also put the positive infinity because it will make the function undefined. So the domain of our function is the set of all the numbers on the number line. And on the number line, the set of all the numbers there are known as the set of all real numbers, meaning the domain of our quadratic D is, we are looking for x's, the x is our domain, such that x is a member of all real numbers. Now we have seen two types of functions. We have seen linear. All right, we are trying to find the loophole. The domain is all real numbers. We have seen quadratic. Linear means highest power is 1. Quadratic means highest power is 2. The domain is all real numbers. If the power is 3, we are going to have cubic. If the power is 4, we are going to have quartic. If the power is 5, obviously we are going to have quintic. 6, we are going to have sesquic, and so on. What do you think? Looking at what we have done so far, what do you think that if the power is 3, the domain will be? If the power is 3, we are having s cubed maybe plus 1. What do you think the domain of this function will be?
It will still be a real number.
It will still be a real number.
Real number.
A real number, good. Because if we put 0 in there, all right, even without the number line, Remember, there are three numbers we are testing. We are testing 0, we are testing any positive number, we are testing any negative number. If we put 0 in there, we are going to have 0 plus 1, which is 1. 1 is real. Then we test positive number. We can put 1 in there. 1 cube plus 1, that is 2. That is real. Then we test negative number. Negative 1 cube plus 1 is equal to 0. 0 is real. So all the numbers on the real number line makes the function defined. So for cubic, the domain will be real numbers. What about quartic? Real numbers. And
Still
then
real
quintic
numbers.
is still real numbers. Therefore, what is the domain of all polynomial functions?
Set of all real
Set
numbers.
of all.
The set of all real numbers. So exam-wise, you have determine the domain of this function. Y is equal to 3x to the power 40 plus 2x to the power 3 minus 1. What is the domain of this function?
The set of all
It's a
real
real
numbers.
Why? Can you briefly tell us why the domain of this will be the set of all real numbers?
Because quadratic.
No, this is not quadratic. Quadratic
No.
means you have to the power 2.
It's a
This is
quintic.
to the power 40. This is the power 40. What kind of mathematical expression is this?
Algebraic expression.
Polynomial expression.
Very good. Yes, this is a polynomial. All right, this is a polynomial. It has multiple terms, and none of the exponents is negative nor fraction. So this is a polynomial. We have established from what we have done so far that if we have a polynomial function, the domain is the set of all real numbers. So exams, you might miss something of this form. Y is equal to 3x to the power 40 plus 2x to the power 3 minus 1, representing the rate of growth of maybe bacteria, maybe the rate of growth or the rate at which malaria or the rate at which the coronavirus is spreading within a region. Determine the domain of this expression. It is going to be the set of all real numbers. It is going to be the set of all people within that interval. Any human being within the interval where the virus is can come into contact with it, or the virus can process you and make you fall sick. So the domain, if you have the function to be polynomial, that is where the difficult task is. Can you identify a polynomial if you see it? If yes, then the domain of such an expression will be the set of all real numbers. You don't need to do any computation at all. As long as you can classify a function as a polynomial function, the domain is always going to be the set of all real numbers. Now let's look at when we don't have polynomial functions, but we have rational functions. When we have rational functions, first of all, let's look at what rational numbers are. Rational numbers are numbers which are in fraction forms. All right, any number you can write as 1 over 2, 2 over 1, 4 over 3, 3 over 4, and so on. Any number that can be written as a fraction or any number in a fraction form is a rational number. Therefore, if rational numbers are numbers in fraction form, rational functions are functions in fraction form. So this time we are not looking at just y is equal to f of x, but we are looking at functions of the form y is equal to f of x divided by g of x. These are what are known as rational functions. So these are rational functions where the numerator is one function, the denominator is another function. Now let's see if we can find the domain of these rational functions. This is where a little bit of twist comes in. We realize that to find the domain of a function, we assume that we are going to pick all the numbers on the real number line, except the minus infinity and positive infinity. Those are the numbers we are not picking. All right, it makes the function break down, makes the function undefined. And so the numbers that we used in testing are 0, any random positive number, any random negative number. However, we see that this is in a fraction form. And so we don't necessarily need to do this. All we need to find is the specific numbers that makes the function undefined. This is in a fraction form. The only way this fraction here will become undefined is if the denominator is equal to 0. That is the only way that this function here will be undefined. If the g of x becomes 0, then you have f of x divided by 0, which is undefined. So those are the numbers that we don't want on the real number line or in our domain, because it will make the function undefined. So this time we don't necessarily need to test all the numbers on the real number line, because the functions that we'll be looking at are the numerator function polynomial, the denominator function polynomial. And so under assumption from what we have discussed earlier on, if we have a polynomial, the domain will be all real numbers. However, we have a denominator, and so it is not going to be the set of all real numbers, but the set of all real numbers minus the numbers that makes the denominator become 0. Therefore, if 1, positive 1, is what will make the denominator become 0, then the domain becomes x is such that x must be all real numbers minus, please, in terms of sets, we don't do minus with a subtraction, we do the backslash. Minus, we put 1 into a set form, and then we close the curly bracket. Meaning, the set of all real numbers, all right, makes the function defined, except the number 1. And at this level, we are not also going to be writing except. I know we are used to writing except, so you write all real numbers except 1. No, we are not doing this again. All right, so to write the except 1 in terms of mathematics, we do backslash, meaning we are subtracting, backslash the set containing 1. This is a set, so if you are subtracting, you cannot subtract a number from a set, but you can subtract a set from a set. That is why in here I have put 1 in curly brackets. If you put a number in curly brackets, it becomes a set. I can just write real numbers minus 1. This is wrong. You cannot subtract a number from a set. So let's look at example, and then we'll also see the strategy here. Given y is equal to 3x divided by x plus 1. To find the domain of this function, we are going to look at the numerator function. The numerator function is a polynomial. Denominator is also a polynomial. And so we are going to assume that the domain will be the set of all real numbers. All right, so my domain is x is such that x must be in the set of all real numbers. This would have been my domain. However, there is a denominator side, and we must avoid the denominator becoming 0. Therefore, the only number that we should avoid from minus infinity to positive infinity is the number where x is equal to negative 1. If x is equal to negative 1, the numerator becomes minus 3 divided by, the denominator becomes minus 1 plus 1. We have minus 3 divided by 0. This is minus undefined. The function breaks down. And so we don't want -1 within our domain. So the domain would be the set of all real numbers minus the set that contains -1. Or in senior high level, we would have just written the set of all real numbers except -1. This is what we would have done, and then close the curly bracket. However, we are not in senior high anymore. And so with this, our big boys and big girls level, we are going to write it in a different way. We are going to put the -1 that we don't want in a set form. In a set form becomes -1 within a curly bracket. We subtract this set from the set of all real numbers. So set of all real numbers minus is backslash the set that contains -1, and then we close our curly bracket. This is the domain of this function. Y is equal to 3x over x plus 1. The domain start with must be the set of all real numbers. Then backslash, it means you are going to subtract a number. So another set. Slash the x that will make the denominator become 0. So that is what you put in the second set. Another example, maybe 2 more examples, then we take questions. Y is equal to 4x minus 1 divided by maybe 3 minus 2x. To find the domain, we look at the numerator, it is linear. We look at the denominator, it is also linear. Therefore, the domain would have been our D is equal to x such that, I need to also mention that this such that sometimes you can also use the column. All right, so either this, the vertical straight line, or the column, that is also accepted. So x is such that x must be in the set of all real numbers minus, we open curly bracket, close the curly bracket. What we put in here is going to be the set of numbers that makes the denominator become 0. So sometimes it's easier to guess, like in the first example. Sometimes it's not easier to guess, like in this second example here. And so we don't want the denominator become 0. So we have 3 minus 2x. Please do not become 0. 3, you must not be the same as 2x. Divide here by 2, divide here by 2, 2 cancels 2. Therefore, x, you cannot be the same as 3 over 2. So if my x is 3 over 2, the function becomes undefined, because if I put 3 over 2 here, the denominator becomes 0. So that 3 over 2, we put it here. Like I mentioned earlier on, would have been x is in all real numbers, then you write a set 3 over 2, because 3 over 2 is what made the function undefined. But this time around, we are not writing a set. Just simply put the backslash, the 3 over 2, put it inside curly bracket, and do not write the except. One more example, then we'll take questions. Y is equal to maybe a 3x plus 2 divided by x squared minus x. To find the domain of this function, we look at what the functions are. We look at the numerator, that is linear. We look at the denominator, that is quadratic. We know that the domain of linear and quadratic is the set of all real numbers. So the domain will be D is equal to x is such that x must be in the set of all real numbers backslash, I open curly bracket. Within this curly bracket is where I'm going to put the numbers that makes the denominator become 0. Then you close the curly bracket. That corresponds with this curly bracket here. All right, so we go to the denominator, look for the numbers that makes the denominator become 0. Sometimes it's easier to guess, sometimes it's not easier to guess. All right, one example is in this case. And so we know that we don't want the denominator to become 0. So we have 2x of x squared minus x. Please don't become 0. We have x in the first term, x in the second term. We can factorize the x out, and we are left with x minus 1. Please do not become 0. Then we can equate this and that, meaning I'll have my x not being equal to 0. Then I'll pick the second term, which is x minus 1 not being equal to 0, means x must not be equal to 1. So there are two numbers that makes the denominator become 0. And those two numbers are 0 and 1. Where I put those numbers are in this bracket here. So the domain is the set of all real numbers minus the set that contains 0 and 1. We could have also written x is in the set of all real numbers except x is equal to 0 or x is equal to 1, or x must not be equal to 0, x must not be equal to 1, where x is not equal to 0 and x is not equal to 1. But to avoid all of these English, let's try as much as possible to use the backslash. Put the numbers that you don't want within curly brackets, and then you close the curly bracket. Any questions so far? I'm not sure you do have questions at the moment.
Madam, please, can you scroll down so I see the previous example? Yes. It's okay. Yeah.
Madam, please go over this one again.
The last one. Okay, I'll do that.
Madam, I mean this one. The second
this
one.
This second one. Okay, so
yes,
why?
please.
Madam, the rational functions, go over them again, the examples.
Okay, we'll take more examples of the rationale. Let's take more examples of the rationale. So another example, can someone give us any example? You just put one function at the top, one function at the bottom. Any example?
Y equals 4x plus 3
divided by
plus 3 minus 4x.
All right, thank you. So let's look at this. Is a rational function. Yes, because it has a numerator and it has a denominator. We look at the numerator, it is linear, it's a polynomial. Denominator is also linear, it's a polynomial. So we'll start with our domain is x. We are looking for x's. That is what the domain represents. And these x's must all be in the set of all real numbers minus open bracket. This is where we are going to put the real answers in. Minus the set of numbers that makes the denominator become 0. If it is easier for you to identify the x that will make the denominator become 0, you come and put the number there or the set of numbers here. But since we don't know the set of numbers that makes the denominator become 0, it means that we don't want the denominator to be 0. So I'll pick my denominator, which is 3 minus 4x. Please, I don't want you to be equal to 0. Then I look for the x. All right, so this is linear. To look for the x, I can either send the 3 to the other side or send the 4x to the other side. If I send the 4x to the other side, then I have 3 must not be equal to 4x. I'm looking for the x, not 4x. So to get rid of the coefficient or the number attached to the x, I'll divide here by 4, divide here by 4. The 4 will cancel the 4, so my x must not be equal to 3 over 4. Therefore, there is only one number that will make the denominator become 0. And that number is when that x is 3/4. And we can test. If we put 3/4 in the denominator, we'll have 3 minus 4 times 3/4. 4 here, 1, 4 there, 1. We are left with 3 minus 3. This is equal to 0. The denominator goes to 0. So we don't want the x to be 3/4. Therefore, my domain is all real numbers minus the set that contains 3/4. Another example.
Madam, before that, I have a question.
Okay.
Please, when you are done finding the x, is it necessary for you to put it in the equation to see if it works perfectly?
No, you don't. No, you don't need to. But to verify.
Okay.
That is just to
Hello,
verify.
madam.
Yes, please.
Hello, madam.
Yes, I can hear.
Do we always work for the denominator?
Yes, because the denominator is the troublesome one. It's only the denominator you work for.
What if we have an equation whereby we need to work on the numerator?
You don't need, if you have polynomial at the top, polynomial at the bottom, no, you don't need to.
What if one isn't a polynomial function?
Then that's a different function. That is why I stated earlier on that we are looking at polynomial at the top, polynomial at the bottom.
All right, thank you.
Yes, okay.
Hello, madam.
Yes, please.
Please, I saw this question in the PDF, the functions PDF. It was f of x 5 over I divided by x raised to the power 2 minus 9.
Sorry, can you repeat that?
The question was f of x 5 divided by x squared minus 9.
Okay.
Yes, please.
All right, so let's work this out. Is this a polynomial? Yes, it is a polynomial. Sorry, is this a rational function? Yes, it's a rational function because I have one, and it's also a specific type of rational function that we are discussing. I have polynomial at the top. This is a polynomial. It's a constant polynomial. It is not interesting because we are not discussing it. We are discussing functions that can move around. Constant, it has no variable to move. And so although it is an uninteresting function, it is also a function, it's still a function. So I have constant polynomial at the top. The domain will be all real numbers. I have quadratic at the bottom. It's also a polynomial. So the assumed domain would have been the set of all real numbers. Right, so here my domain, I'll quickly write down, I'm looking for x's. The x must be in the set of all real numbers minus, I'll put down curly brackets. This is where I am going to put the answers I'll get from the denominator from. And then I'll close my bracket. Now we go back to the function. We don't want a situation where the denominator is equal to 0. So my denominator, which is x squared minus 1, must not be equal to 0. There are two ways of going about this equation here. One, you can do the difference of two squares and factorize it, or you can just simply send the negative 9 to the other side, find square root of both sides. All right, so let's do the two. If we send 9 to the other side, it means we are going to get x squared must not be equal to 9. If we find square root of both sides, then we'll have x must not be equal to, x must not be equal to plus or minus 3 because square root of 9 is negative 3 or positive 3. The other way of solving it is where if you have x squared minus 9 not equal to 0, you can group this as x minus 3, x plus 3. This must not be equal to 0. Then you pick the first, must not be equal to 0 means x cannot be equal to 3. You pick the second, must not be equal to 0 means x must not be equal to minus 3. So in both cases, you get the same result. It's up to you to decide which one you want to go with. That is an aside work. So the two numbers we don't want are -3 and +3. Where do I put that? I put that in this bracket here, -3 and +3. That gives us the domain of the function. Are we still lost? So to find the domain of rational where the numerator is polynomial, denominator is polynomial, the domain is going to be the set of all real numbers minus the numbers that makes the denominator become 0. Because if the denominator becomes 0, the function becomes undefined. Those are the numbers that we want to remove. Last one, then we can move on to another thing. Y is equal to maybe 4x plus 1 divided by 2x cubed plus 7x squared plus 7x plus 2. To find the domain of this function, we need to understand the type of function that it is. We have one function at the top, there's a denominator, therefore this is a rational function. If it's a rational function, we also need to take under consideration the type of function that is at the top, the type of function that is at the bottom. What is at the top is polynomial. So the domain, the assumed domain, all right, the assumed domain is going to be the set of all real numbers. Then we subtract the numbers that makes the denominator become 0. All right, so subtract numbers that makes the divisor equal to 0. Because if the divisor is equal to 0, then the function becomes undefined. All right, so my domain will be, we are looking for all x's such that x must be the set of all real numbers minus or excluding the set that contains these numbers. Right now we go to the function and then look for the set of numbers that makes the function undefined. Those with calculators, please, can you help us find the numbers that makes the denominator equal to 0? Those with calculators, if you go to shift mode and then 5. Shift mode 5, then you pick the polynomial with power 3. Your A is equal to 2.
-1.
Your B
-2.
-2, -1, and then
-1.
Is the -1
over 2.
-1 over 2.
Yes, madam.
Okay, so these are the three numbers. Where do I put the three numbers? In this curly bracket here. So we have -2, -1, -1 over 2. This is the domain of the function up there. You are allowed to use your calculator to determine the numbers that makes the denominator become 0. If you do that, you have not defined anything. Or you can go through the tedious approach of doing factorization into 3 factors, equate every factor to 0 and solve for x, which is tedious. You can also use your calculator. Please, those who don't know how to use your calculators to do it, if you know someone around you that knows how to do it, it's very beneficial. All right, I think it's shift mode 5, and then you pick the cubic. It will ask you for what A is. The A is the number attached to the cubic. Your B is the number attached to the quadratic. Your C is the number attached to the x term. And then your D is the number that is attached, the constant term. And then you press on answer, or I think you press on enter, something of that form, and then you get the zeros of that cubic function. Please, any questions so far?
Madam, can we solve this one?
Can we?
Solve this one, the one they use the calculator. Can you solve it? Yeah.
No, that's algebra. That is algebra. At the moment, use your calculator. I will find time to do the solution.
Hello, madam.
Yes, please.
Madam, with the calculator, it's just mode and 5.
It's what?
It's just the mode. You press on mode and you press on 5.
Okay, so you press on mode and then you press on 5.
On
Those
5.
who don't
Yes,
know,
madam. And then yes, madam.
and then you pick the big one. So if it's quadratic, you pick them. Okay, thank you very much.
Madam.
Okay.
But madam, I have the calculator. I think Casio FX82 MS, but I can't see more than 5. I don't know whether mine is the old version or something.
Hey, it's been ages since I used calculator. It was.
Mine is Casio FX.
Yes, you need to get the scientific calculator so that it will make it easy for you.
Is that not the same?
Oh, okay.
Is it not the senior high scientific calculators we use?
No, we have two
Yes,
types.
madam.
We have two types.
Okay.
So it seems you are using the Casio, so you try to upgrade
The most recent one is 99 FX 991.
Yes, 991 ES. 991 ES.
Okay.
That's
FX 991.
991 ES.
Yes.
Plus.
Okay, thank you.
Yeah.
Madam, please, I want to also ask if you can get a slide on this.
A slide on. You don't have the material on the LMS.
Okay, then I'll need to check. Sorry.
Okay, but you can. I don't know whether the institute has informed you whether it's authorized, but the previous session, what we were doing was, since sometimes you cannot wait for the institute to send you the video at the end of the lecture.
Yes.
Once you're about to start your session, if your device allows you to do screen recording.
Okay.
Yeah, so that you can issue a screen recording. If it's your phone, if it's a tablet or a computer, I'm sure if you press a few keys, or if you have even a third-party software, it will allow you to do screen recording, so that as soon as the session ends, you already have the lecture video. So any question, if you have any doubt, you go back to the video, and then you have the whole lecture once again, instead of waiting for the institute. Yes, so instead of waiting for the institute, you can also issue screen record on your device. It's academic work. I don't think you are violating anything, right? So that you can get the video as compared to having the lecture notes or the slides, because you are working, you have families, you won't get the time to be picking the book and then be reading. No, it's not possible. But if you have the lecture video, you are in the toilet seat, you take your phone to the toilet, and then you'll be watching it. You are working in the kitchen, wherever, you put your phone on the counter, and then you are watching the video. You're even listening to the audio. It will help. Yes, do recording. Get the video instead. Okay, that will help. That is very helpful. Do screen recording. Yes.
Please, on laptop, how will we screen record? Do we have any
I
application?
know for Mac allows you to do screen recording. If you are using they have this inbuilt media player that allows you to do screen recording. I know for Mac, but for Windows, I don't know.
I think for Windows, you press the Windows key plus Shift plus R.
Okay. Window key plus R.
Shift plus R, yes.
That's
it's screen recording.
R is record. So S must be screenshot, yeah. So let's do it. Okay, that will help. For all your lectures. Yes.
Please, let us evaluate this one again. The x squared minus 9.
I know you get x or into bracket x minus 3. So at the end of the day, you get x equals to 0, then x
You mean
equals
this?
positive 2. No, x minus x squared minus 9.
Okay, so you have y is equal to 9 divided by x squared minus 9. Oh, it's 5 up here. It doesn't even matter.
Yes.
We are looking for all that will make the denominator go to 0 and remove it. Or another way of thinking about it is you don't want the denominator to go to 0. So you have x squared minus 9. Please do not go to 0. If you are doing the factorization, you have x minus 3, x plus 3. Please do not go to 0. If I pick the first factor, x minus 3 must not be 0. Take the second factor, x plus 3 must not go to 0. Then we come to this. Here, x must not be equal to 3. We come to this, x must not be equal to negative 3. So there are two numbers. So the domain will be x such that x is in where? All real numbers minus negative 3 and 3. Or did you get something different?
Madam, what if the x is equal to cubic 2?
Madam, what I got was x equal to 0, then x equal to positive 3.
Hey, how?
Madam, let him fix that into the equation and find out if it is correct. But what you taught us, the minus 3 and minus positive 3, when you put them inside the equation, you get a correct answer.
Yeah. I don't know how you.
So
if you put 0 in there, I think you mentioned x equal to 0. If you put 0 in the function, you have y is equal to 5 divided by 0 squared minus 9, and that is 5 divided by minus 9. This is not plus or minus undefined. That's a real number. So 0 is not part. 0 is not part of the numbers that you don't want. No. After getting the numbers, put them back into the denominator. If it becomes 0, it means your answer is correct. If it does not become 0, it means your answer is wrong. All right, so you can verify to see if your answer is wrong or if your answer is.
Okay. Thank you.
Any other question? Those who don't know how to do that, please make sure you find a solution to it. How to find the numbers that makes the denominator become 0 using your calculator, so you don't go through that tedious approach, because it won't fetch you much. It won't fetch you much of, unless it's under algebra. Under algebra, you have to show working. The zeros of cubic, the zeros of quadratic, zeros of linear, and so on. You have to show working. But under calculus, you don't need to show working. You are applying your knowledge in algebra over here. So doing this one by one is not going to fetch you marks here. That is why the person will say we should solve it. I said no, because it is not under calculus.
Okay.
All right. Last
Madam,
one for you.
please.
Yes.
Please, do you have practical application for this rational function, like the one you give us for the linear function?
What do you mean practical application?
Like the linear function, you give us a practical application concerning, let's say, the pandemic and the COVID-19.
Oh yeah, there are so many applications. Most of them you'll be getting what do you call it in the upcoming quiz. An example is you have a function y is equal to 3 divided by maybe x minus a 4. This function here could represent the delay of server's response. So the delay of a server All right, the delay in the response time of a server. So this here could be maybe on the LMS. All right, as the number of students going on the LMS is increasing, you realize that your delay is going to be higher and higher. Therefore, sometimes if the number of students reaches the peak or the capacity that the server can handle, you get that system down, error message. I think the banks experience it a lot. Sometimes if the transaction is so high, you go there and they say, we have network issues and all that. And that's because the server has reached its maximum capacity. And so if we have a function here that represents the delay of a server, meaning if you don't want the maximum capacity could be when x is equal to 4. When x is equal to 4, you're going to have y is equal to 3 divided by 4 minus 4, 3 divided by 0, and that is undefined, meaning you're going to get that system timeout, or you're going to get system overload. You're also going to experience, that's when you're trying to open a page, you see that circle that keeps turning and turning and turning, especially it happens a lot with apps. If you're opening an app, you have a circle that keeps turning and turning and turning on your screen. Sometimes your screen is plain white, and then you have a small circle.
The buffering.
It's called what?
Buffering.
Very good. The buffering. Very good. All right. The system will be buffering because the delay is getting bigger and bigger because the amount of requests on the server is getting bigger and bigger. The amount of requests is getting closer and closer to 4, or it's even equal to 4. And so there is going to create a lot of delay on the system, meaning the function, which is y is equal to 3 divided by x minus 4, the function is becoming either minus or plus undefined. It has reached its maximum capacity. So sometimes you get error message 404, or sometimes you get redirected to another system or even another page. That is one practical application. In terms of network, telecommunication network, when the server reaches its maximum capacity, for example, during AFCON or during a World Cup, where a lot of people are streaming, there's a lot of even telephone communication. The demand on the server keeps increasing and increasing. Therefore, as the number is reaching its capacity, all right, as the number, maybe in this equation here, the capacity is equal to 4. As the number of requests on the network is reaching its maximum capacity, it is going to be plus or minus undefined. The function is the network. It is going to be plus or minus undefined. All right, so you don't want a situation where the server, its maybe capacity is, let's say 400 transactions. That means that if within that specific interval, you have 400 number of transactions, your server is going to be under a lot of load. Therefore, you have system crashing there. In terms of telecommunication, when it's festive occasions, mobile money transfers and all of that is going to put a lot of load on your server or even on your network. Therefore, a whole lot of information is going to be lost along the way. People's phone calls are going to be dropped along the way. Mobile money transaction is going to be delayed along the way and all of that. So that is one of the things that happen as bandwidth, or even as number of people, or even as the number of transaction increases. How will your server, or how would whatever it is that you're using, able to handle it? So that is one application of the polynomial. I think I've set a question, an end of semester question on that, where I've given you a function in terms of in terms of a rational function. All right, so you have a rational function, f of x divided by g of x. And the question says this function here represents the temperature. of a small server room on campus, preferably at Abeka campus, because Abeka campus has a small campus. All right, so we have a small room where we have a small server there, and we have a function that represents the temperature of the server room. Determine how long it will take for the technician to come and fix the AC if at this time the AC goes off. So with this example here, you notice that the only way that the technician might get an alert is if the temperature within the room becomes so high that it is almost equal to a huge number, positive infinity. And the only way that the function becomes positive or negative infinity is if the denominator becomes 0. So example, y is equal to f of x divided by t minus 4. This here represents the temperature of a small server room at Abeka campus. At time t is equal to this, the AC within the server room went off. There are no windows. When will the technician get an alert that the temperature is abnormal? Therefore, I need to go in the server room and then work on the AC so that the temperature will be normal again. The temperature will become abnormal if the temperature is undefined, meaning we are looking for the set of all times at which the denominator is not equal to 0. So any time where the t is equal to 4, as soon as the time is maybe 4 hours time, I will have f of 4. All right, so the function is y is equal to f of t divided by t minus 4. At t is equal to this, the temperature or the AC went off. So the temperature is going to go higher. The room is going to be heated up. There is an alert system that if the temperature reaches an abnormal temperature, the technician will get an alert, because you don't want the server and the equipment there to heat up and then spoil gadgets. And so what time or how long will it take for the technician to get an alert? The technician will get an alert if the temperature becomes abnormal. And abnormal means the temperature is going to be undefined. This is a rational function. The only way that this rational function will be undefined is if the denominator is equal to what? 0. Therefore, if t is time, we don't want t to be equal to 4. Because if t is 4, the denominator becomes 0, the function becomes undefined, meaning the temperature is heated to abnormal degree. So the number of hours it would take the technician to get an alert is t is equal to 4. Any time below that, all right, it's acceptable. You can go in there and fix. But to reach abnormal temperature, meaning that the temperature the hours it would take for the temperature to reach abnormal temperature is when t is equal to 4. So you put a 4 there, the denominator becomes 4. The numerator is not going to be equal to 0, because of the function I put in the numerator. So you're going to get something of the form maybe 8 divided by 0, which is also equal to undefined. So in this case, your domain, the technician will get an alert within 4 hours. Or the domain will be, you are looking for t such that t will be in the set of all real numbers minus 4 hours. Anytime within that, before that 4 hours, the temperature is acceptable. All right, any temperature within 4 hours is acceptable. But any temperature on the 4 and above is not acceptable. That is one application. There are several applications as we go ahead. Any questions?
Madam, another scenario.
Hello, madam.
Yes, please.
So I am pleading if you could touch on this question for me. I think this is what I'm pleading. The y equal to the 4x minus 1 over 3 minus 2x.
Okay, y is equal to 4x minus 3 over...
No, I mean y equal to 4x minus 1 over 3 minus 2x.
Okay.
Yes, please. Thank you so much.
All right. So to find the domain of this rational function, we look at the functions at the numerator, and the function at the numerator is polynomial, meaning if we were to cover the denominator, the domain would have been the set of all real numbers. So we would have written D is equal to X is such that X is in the set of all real numbers. Then we are done. Here after this, we close the bracket and we are done because the function at the numerator is a polynomial. However, that is not the case. There is a top, there is a down. All right. So although if we had covered this, all real numbers would have made the function defined. That is what this means. Any number at all that you can think of on the number line can make the function defined. However, we have something at the denominator side. We have something at the bottom. And so the function is not just the top, but is the top together with the down. So whatever the denominator also decides to say must be taken into consideration because it's not just one function. It is now top and bottom. All right. So this time around, we are not only looking at just the voice of the numerator, we also need to consider what the denominator is also bringing on board. And the denominator says, okay, all real numbers can also make me define, but don't make me 0. If I become 0, the whole function collapses. That is what this means. The numerator says, oh, I can accept any real number. However, the function is not only one voice. The function is 2 voices put together. And so we need to look at the voice or listen to the voice of the numerator as well as the voice of the denominator. The voice of the numerator says, I'm accepting any number at all because I am a polynomial. However, the denominator also needs its own has to bring its own contribution and says, I am at the below. I can also accept all real numbers, but there is only one condition I will not accept, and that condition is I must never be equal to 0, because if the denominator is equal to 0, the whole vehicle is going to break down. Think of it as a car. All right, the wheels are the denominator. The top part of the body is the numerator function. So they must work together for the entire vehicle to move. The numerator says, okay, I can go anywhere. I can go to the past. I can go to the future. I can be at the 0. I can be at the present. Everywhere, all weather, I can go. But the tie says, I can go to the past. I can go to the future. I can be at the present. But I am the one carrying you. And my only condition is that my ties, you must not deflate it. If I am deflated, it means I become 0. I can move you around. You can have all the fuel in the fuel tank. Your engine level might be high. Your radiator, your coolant might be okay. Oil check and all of that, everything might be okay. But if the ties are deflated, if this, which are the ties, are deflated, becomes 0, you can't move the car anywhere unless you go and hire somebody to come and pull the car away. So consider the denominator as the ties. If the ties are deflated, the car is not going anywhere. Mathematically means the denominator must not be equal to 0. So we are accepting the fact that we can move forward, we can reverse, we can also be stationary, meaning we can accept all negative numbers, we can accept all positive numbers, we can also accept 0. But our ties must not be deflated, meaning my ties, what are my ties? The denominator, 3 minus 2x, must not be equal to 0. We have to solve for the x, the value of x that would deflate the ties. So here we can take the 3 to the other side like we are used to. Normal circumstance, you take the constant to the other side, leave the x on one side, or leave the x and then, take the x to the other side. Any of them, you get the answer. So if we leave the x here, 2x, and then take the 3 to the other side, this must not be equal to -3. We are looking for x, so we have to divide here by -2, divide here by -2. This and that, therefore x must not be equal to the negative, and the negative cancel each other, so must not be equal to 3/2. All right, so this is what the denominator says. I'm accepting all real numbers. I'm accepting to go to -infinity. I am accepting to go to positive infinity. I am accepting to be at the current position 0, but I cannot be at 3/2. So if it's going all weather, if it's going to the past, if it's going to the future, if it's being at the present, it is in real numbers, but it is not accepting. So minus, what will the denominator not accept? It must not be 3/2. So we put a 3/2 in curly brackets, meaning we are subtracting the 3/2, which is a set, from the set of all real numbers, and that gives us the domain of the function. So here, we are going to -infinity, we are going to positive infinity, we are going to the present, 0, we are stationary, but at 3/2, we cannot be there. We cannot be at this position. We can go all the way here. We can go all the way here. We cannot be at 3/2. That is what that function is telling us. And that gives us the domain of the function. Is that one clear? So pick the denominator and make it not equal to 0. Whatever you get becomes the exception. And the exception is to write it as must be the set of all real numbers except 3/2. And like I mentioned, please do not put the except here. Do not write except. All right, do the backslash, means subtraction. It means except. Put the number that you get in a set form, because R is a set. You can do subtraction of a set and a number. You do subtraction of sets and a set, subtraction of a number and a number. But since what you are subtracting from is a set, you need to make the number into a set form. That is why I've put them into the curly bracket over here. Is it okay now? Okay.
Yes, madam. I'm most
Okay,
grateful.
Madam,
Yes. Yeah.
in case we find the domain of irrational number, then the x was equal to 0. What will be the function of the domain?
An example of it is this. So
Okay.
here, the only number that will make the denominator 0 is when x is equal to 0. So my domain will be x such that x must be all real numbers minus 0. This is what would have been your domain. Put a 0. 0 is a number. Put a 0 into a set form and subtract it from R, because R contains 0 as well. You don't want it there. So to remove it, you do the minus, put the 0 into curly bracket.
Okay, thank you.
All right. All right, I think our time is up. Please, once for those who are able to do the screen record, send it to the rest. I don't know how long it will take the institute to give you the screen record, and the device I'm
Madam,
using
please,
also that's allowed.
please,
Yes.
please, thank you for your time.
Okay.
God willing, next we will be meeting. And I understand you people have 2 campuses, so I don't know which place are we coming.
I think our Tesano campus.
All right, thank you.
Yeah. All right.